Hi guys, so in this video series, I'm going to demonstrate the solution procedure for problems involving dry friction. Okay, so before we proceed, in the second example that I gave to you in the lecture slide, I noticed that there are some mistakes to the question. I actually copy pasted some of the formatting from the question and I forgot to delete it. So this first few lines is not necessary. So maybe you get a bit confused when you read it for the first time. Okay, now given in this question is a problem involving dry friction on an inclined surface. It was stated in this question that at an inclined angle of 25 degree, the vending machine or the object begin to slide. So if it begins to slide, it means that it begin to slip. So based from the previous lecture series, you know that when an object begin to slip or begin to move over a surface, then the friction between the contact surface would be equivalent to the friction limit or Fs. Okay, so this friction limit can be calculated by using the formula of mu n, whereby mu is the magnitude of coefficient of static friction. Okay, so this question actually asks you to find what is the value of the mu s, okay, the coefficient of static friction. Okay, let us think on the strategy on solving for this kind of problem. First, definitely you need to draw the free body diagram. And based on the previous lecture, there are 4 elements that you need to include in the free body diagram, which is the pushing or pulling force. And then the second one is the friction force. And then the third one is the normal force at the contact surface. And the fourth one is definitely the weight of the object. But in this case, there is no pushing or pulling force exists in the system, so we can just eliminate this part. Okay, so there are 3 items that we need to look for. Once we have appropriately defined the free body diagram, then we can find the magnitude of the friction force and also the normal force based on the equation of equilibrium. Okay, and then finally, using the magnitude of friction limit to be mu n, we need to find what is the magnitude of mu. Okay, let's begin. Let's draw the free body diagram. So this is the direction of the weight of the vending machine. Okay, so you know that the inclined angle is 25 degrees, so definitely the angle over here will also be 25 degrees. Okay, so based from this checklist, the W is done. Okay, the next thing is we need to draw the free body diagram of the normal force. So let me just delete this, and the normal force would be in this direction. Okay, so normal force should be perpendicular to the contact surface. Okay, since the contact surface is in an inclined angle, so the normal force will also be in an inclined direction as well. Okay, now the third item that we need to include in our free body diagram is the friction force. So recall that this vending machine is on the verge of slipping. So the friction force should be equivalent to the equation of mu n. Okay, now if you look at this particular diagram, there is a tendency for the vending machine to fall downward. Okay, bawah menurun daripada the inclined angle. So therefore, the direction of the friction force would be in the opposite direction, which is this way. Okay, so this F is equivalent to mu n. Okay, so now we can proceed to the second step, whereby we need to find what is the magnitude of the unknowns in this case, which is the F and also the n. The W is also unknown, I think. Okay, anyway, let us apply the equilibrium condition for this particular system. Okay, before we proceed with the equilibrium condition, you notice that the direction of the forces in this inclined angle ada multiple forces yang sangat bengek tu kan. So, in order to ease my computational process, so I'm going to define this direction as my X and this direction as my Y. So, therefore, I can convert the direction of the W or the weight of the vending machine into an equivalent X and Y direction. Okay, so if I were to convert the W in the X direction, it will become W sine 25. And if I were to convert it into an equivalent Y direction, it will become W cos 25. Okay, now only I can proceed with the appropriate equilibrium condition. Now, applying the equilibrium condition equation in the x direction, slightly inclined at 25 degree over there. So we know there are two elements of forces in the x direction, which is this W sine 25 and also this mu n. You can just substitute these two items into your equation and you will get this expression to be equivalent to 0. We can't really solve this particular equation yet because there are three unknowns. So let's just call this equation to be equation 1. So now let us apply the equilibrium condition in the y direction. So there are two items in the y direction, which is the n and also the w cos 25. Okay, so just substitute these two components into our equation and that sums up to 0. So now let us rearrange this equation so that the n will be on the left side and it will be equivalent to w cos 25. Okay, now let's call this equation to be equation 2. Now, the next step is let us try to substitute equation 2 into equation 1. So in that case, equation 1 would become w sine 25 minus mu multiplied with the substitution of n, which is w cos 25. So that will be equivalent to 0. So now if you look at this particular equation, there would be only two unknowns this time around, which is the w and also the mu s value. Anyway, if you see a combination of sine and cos expression in a single equation, you can actually simplify it to become tangent. Oh, how is that? Okay, let me just rearrange this particular equation. On the left side, it becomes mu s multiplied with w cos 25. Imagine that I'm transferring it to the other side. It will be equivalent to w sine 25. Okay, now if I were to transfer the w cos 25 into the right side of the equation, then my mu s would become w sine 25 divided with w cos 25. Okay, so you see this w can be cancelled out and sine over cos is equivalent to tangent. So that is basic trigonometric rule. So you can actually get the magnitude of the coefficient of static friction just by using the expression of tangent 25. Senang je. So now if you use your calculator, you can easily get the coefficient of static friction of or mu s to become 0.4663. Okay, so basically dah siap. So basically, this step, we're not solving to find the f or n. So we are actually solving to find what is the magnitude of mu s. Okay, now let us just do a quick check. I'm just curious. I just want to know, will this vending machine slip first or tip first? Okay, so in order for us to know whether it will tip or not, we have to know the magnitude of the x or the position of the frictional force. So there is only one way where we can get the magnitude of x, which is by applying the equilibrium condition for moment. Okay, for the calculation of moment, we need to define where is the rotation point. Let's say the rotation point is over here and we'll call it point O. Okay, so the distance of the resultant frictional force and normal force to the centroid of the vending machine is x. Okay, now we are going to apply the equilibrium condition of moment at point O. Okay, this vertical force of W cos 25 will create a moment at point O at a distance of x. Okay, and the direction of the moment is counterclockwise, so it will be positive. And then this force of W sine 25 will also create moment at point O at a distance of 0.75 meter. Okay, and the rotation of the moment caused by this force would be in clockwise direction, so the magnitude would be negative. So yang lain-lain tu ada ke tak? No, because it passes through the rotation point, so there would be no moment produced by either n or the frictional force. So we can actually sum up these two expressions to 0. So as you can see in this particular equation, again, there is an interesting combination of sine and cos 25 degree. You can actually simplify this particular equation by forming the trigonometric function of tangent 25 degree. So let's see how we can do that. On the left side of equation, we just remain the w cos 25 multiplied with x, and then we transfer the remaining expression in the opposite side, in the opposite direction. So this will be equivalent to 0.75 multiplied with w sine 25. If we want to get the value of the x, let us transfer the w cos 25 to the other side. So this equation on the other side will become 0.75 w sine 25 divided with w cos 25. So based on this fractional expression, the w can be cancelled out, and then the sine 25 over the cos 25 can be converted into an equivalent tangent 25. So you can simply use your calculator and you will get the x distance to be 0.3497 meter. What does it mean here? Okay, so if I were to sketch the vending machine briefly over here at this side, from the center of the vending machine to the end line of the profile of the vending machine, the distance is 0.45 meter, whereas the position of x, which is the position of the frictional force, is 0.3497 meter, so which is slightly less than 0.45 meter distance of the centroid of the vending machine. So in this case, we can say that the position of the frictional force is still within the contact area of the vending machine as well as the land area over there. So we can conclude from this equation that the machine will slip first. Okay, it will not tip yet. It will slip first before it can tip. Okay. Okay, now let us look at this example. Okay, it involves an object which rests on two surface. Okay, so this is a uniform 10 kilogram ladder. So we know the weight would act in the middle of the ladder, and if you want to convert the mass into an equivalent weight, we use a formula of mg. So m is 10 kilogram and the gravitational acceleration is 9.81. So the weight of this ladder acting in this direction will be 98.1 Newton. Okay, so given in the question is that it rests against the smooth wall B. As you can see, there is a contact point between point B to the smooth wall. So as long as there is contact, then that means there is a direction normal force in a direction perpendicular to the surface of the contact area. So in this case, the NB would be over here. How about the friction? Okay, there would be no friction at a smooth wall. Okay, now also given that the N rests at point A. So again, you can see at point A, it is touching with the floor, kan? So if it is touching, then there is a reactive normal force acting in a direction perpendicular to the contact surface. Okay, so the floor is a rough horizontal plane, so definitely there will be a friction acting at that particular area. So if you imagine the ladder to drop, then most probably it will drop in this particular direction, right? So therefore, the direction of the friction would be in the opposite direction to the possible movement of the ladder, which is this way. So this question also gives that the coefficient of static friction is mu equals to 0.3. So they wanted to know what is the angle of inclination theta and what is the normal reaction at B, which is NB, if the ladder is on the verge of slipping. So if it is on the verge of slipping, then the magnitude of the friction limit is equivalent to the formula of mu n. Okay, so you just substitute mu n in this equation, and given that the mu is 0.3, so therefore the friction at point A would be 0.3 and A. So the question asks you to find what is the angle of inclination or theta when the ladder is on the verge of slipping, and also you need to find the magnitude of the normal reaction B, which is NB. So before we proceed with the computational analysis, let us extract important information on this diagram. Okay, if you look at this particular triangle, so the distance from the floor to point B would be 4 sine theta. Okay, accordingly, the distance from the wall, the smooth wall, to point A would be 4 cos theta. And since we wanted to get the distance of W, so this W is acting in the middle of the ladder. Okay, so therefore we can just divide it into 2, whereby 1/2 of it is half of 4 cos theta, which is 2 cos theta, and the remaining distance is also 2 cos theta. Okay, now we can solve for the unknowns by using equilibrium equation. So let us apply the equilibrium condition in the x direction. So there are two items in the x direction, which is this and B, and also this 0.3 and A. So you put these two items into your equation and it will sums up to 0. So there are two unknowns in that equation, which is NB and also NA. So we cannot solve it yet. So let's just call this equation to be equation 1. Okay, now accordingly, let us apply the equilibrium condition in y direction. Okay, so there are also two items in the y direction, which is the weight 98.1 Newton and also this N A. Okay, so you put that two items into your equation and it sums up to 0. So there is only one unknown in this equation, whereby you can easily solve for NA to be 98.1 Newton. Okay, now that you know the magnitude of NA, you can substitute the value into equation 1. So if you substitute it into equation 1, it becomes negative NB plus 0.3. NA tadi dah kira kan, it is 98.1 and it sums up to 0. So from here, there is only one unknown. So you can easily solve for the NB to be 29.43 Newton. So the magnitude of NB requested by the question is already calculated, done. So the next thing is we need to find what is the value of theta. So since we already used the equilibrium equation of the x direction and in the y direction, so the next equation that we can consider is the equation of equilibrium for moment. So since there are so many forces acting in the A direction, so let's just apply the moment at point A, okay? Okay, so the force over here, which is the weight of the ladder of 98.1 Newton, will create a moment at point A at a distance of 2 cos theta. So the direction of this moment is clockwise, so the magnitude of this expression is negative. Okay, and then the next force that will create moment is this NB. So the force of NB will create moment at point A at a distance of 4 sine theta. The NB tend to create a rotation at a counterclockwise direction. So therefore, this magnitude would be in a positive value. So these two expressions sums up to 0. Okay, now NB is already calculated previously. Okay, so kita dah tahu the NB is 29.43 Newton. So you just substitute the known value into your equation. Okay, let us first solve for this known value here, which is 98.1 multiplied with 2. It will become 196.2 cos theta. And then don't forget, this one pun boleh being simplified, which is 29.43 multiplied with 4. It becomes 117.72 sin theta, and that sums up to 0. Okay, now as you can see, there is a combination of sin theta and cos theta in the same equation. So we are going to apply the same technique as the previous example. Every time you nampak sin theta and cos theta je, you boleh imagine you can actually convert it into an equivalent tangent theta. So let me just put this 117.72 sin theta on the left side of the equation, and the 196.2 cos theta will be on the other side of the equation. Okay, now let us bring this cos theta to the left side by dividing it, and also the 117.72 to the other side by dividing it as well. So your equation will become sin theta divided with cos theta will be equivalent to 196.2 over 117.72. Okay, so you know sin theta divided with cos theta will be equivalent to tangent theta. So theta can be easily calculated by using the inverse of tangent of the fraction of 196.2 over 117.72 lah. Okay, so you will get the magnitude of the angle to be 59.04 degree. Okay, dah siap. Okay, that is all for now on dry friction. So in the next video, we will extend the concept of friction on wedges pula. Okay, so till then, bye-bye. See you later, alligator.